You've probably heard about the Fibonacci numbers many times. Here they are defined by this sequence, but did you know that they can be used to prove that there exist infinitely many prime numbers? The proof is based on this amazing property, the fact that the greatest common divisor of two Fibonacci numbers is a Fibonacci number. The greatest common divisor of the nth and the mth is the Fibonacci number with index the GCD of n and m. For example, the GCD of the 6th and the 9th Fibonacci numbers is the 3rd Fibonacci number. Now, to prove that there are infinitely many primes using Fibonacci numbers, what we can do is start with a Fibonacci number like f3, and then look for an index that is relatively prime to 3. f4 and f3 have to be relatively prime Fibonacci numbers. Therefore, the primes that divide here do not appear here, so there are new primes appearing here. Now, find an index that is relatively prime to 3 and 4, like 13. 3 times 4, 12 plus 1 has to be relatively prime to 3 and 4, so this one contains prime divisors that do not appear in either one of those. In this case, for example, 2, 3, 233 are actually three different primes, and we can continue in this way and build more and more primes. Now notice this doesn't say that Fibonacci numbers with a prime index have to be prime numbers. For example, the 19th Fibonacci number is composite, but those primes are different from those dividing these numbers because the indices are relatively prime. So in this way we can create infinitely many distinct prime numbers dividing Fibonacci numbers.